Welcome back to the Packet Lab. Today we're going to take a look at OSPF router types. And there are 4 different types of OSPF routers, and an OSPF router type is going to be determined by a router's function and or its location within an OSPF area. So let's start out with the most basic of these 4, and that is an internal router. An internal router has all, now I've got OSPF in question marks and I'll get to that in just a bit here, all interfaces must belong to a single OSPF area. So if you're running single area OSPF, then all the routers are going to be internal. And while I'm going through these definitions, if these don't click, don't worry about it too much, because in the next couple slides we're going to have some network topologies and show you, and it's actually a lot easier to understand the OSPF router types when you're looking at a topology and seeing where the routers are located in relationship to the OSPF areas. It's a lot easier to determine what type of router it is. Okay, and in a backbone router, it simply means it's any OSPF router that has at least one interface that's belonging to area 0, and in OSPF area 0 is a special area. It's referred to as the backbone area. Next up is the area border router, or ABR. This is where the OSPF router types start getting interesting, because these actually have different functionality depending on the type. So an ABR has at least one OSPF interface that belongs to area 0. It's connected to the backbone area, and then at least one OSPF interface belonging to a non-area 0, non-backbone area. So it'll have an interface that's in area 0, and then another one in, let's say area 1, and it's between the border of those 2 areas. So again, this will make a whole lot more sense when you're taking a look at the topologies. And then our final guy down here is the autonomous system boundary router, and that's a $20 word for a router that does redistribution into OSPF. So if you're not familiar with redistribution, just a 30,000 foot view is basically redistribution is when routes are learned from a source that's external to the routing process that you're running. So if you're running OSPF and your router also connects to an EIGRP domain, if you take those EIGRP routes and put them into OSPF, that's route injection or redistribution from another source, and that's what we're talking about here. So it's going to be a router which learns routes, and they're referred to external routes from another source. That can be another IGP like RIP or EIGRP. It can be an EGP like BGP, or it can also be connected routes, or in Cisco another OSPF process. We're not going to get too deep in this. Basically, it's any externally learned routes, any routes that are not learned from your OSPF process that are then injected into that OSPF process. All right, now back to the internal router controversy here. So when I see this definition, almost every time that I see it, it says all interfaces must belong to the same OSPF area. I've also seen it written that all OSPF interfaces must belong to the same OSPF area. And there's a subtle difference between those 2 definitions. In the first definition, it's going to be a router that's running nothing but OSPF and that's connected to one OSPF area. In the second definition, it's just saying that any interfaces that happen to be running OSPF, you could have interfaces that are not they're not running OSPF. They could be running EIGRP or whatever, but the ones that are running OSPF have to belong to the same OSPF area. We'll see this when we go through the topologies, how that subtle difference can be a game changer for certain types of routers. From the Cisco OSPF design guide, it says an area is interface specific. A router that has all of its interfaces within the same area is called an internal router. So that's from the horse's mouth. Now, of course, Cisco OSPF design guide, of course, is in the context of OSPF. So you could also say, well, you know, within the context, they're talking about OSPF interfaces. Anyways, it's not going to be a big deal. It can lead to a little bit of goofiness that I'll highlight a little bit later. But in the real world, it's a non-issue. It's completely trivial. In a Cisco exam, if they do have this come up, you would probably want to know which definition of OSPF internal router they are considering to be gospel. Okay, like I said, when you see this in a topology, it becomes a whole lot easier to understand the OSPF router types. So in our first network here, we have a single OSPF area network. Every interface here is within area 0. So that's going to be, regardless of definition, a internal router. So R2, R3, and R5 are all going to be internal routers, because all of their interfaces and all their OSPF interfaces are all within a single area. They're also going to be backbone routers, because the area that they're in is area 0, and remember, area 0 is the backbone area. So that brings up something important that I didn't highlight in the last slide, is that these types are not exclusive. You can have routers that are up to 3 different types. You'll never get all 4. That's simply because once you become an area border router, you can't be considered an internal router. So you're going to be either or. So you could be a backbone router, area border router, autonomous system boundary router. You could be all 3 of those on one router. and we'll actually see that in action a little bit later. All right, here we are. We see the topology with the OSPF router types labeled, and I'm not going to have a lab section for this. So what I'm actually going to do is I'm just going to bring in the CLI and take a look at this on the CLI. The main verification command for this, and it's in a different slide, but we'll get to it, is show IP OSPF. So let's take a look at this topology in action. Okay, so let's pop on over to R2, and if we do a show IP OSPF neighbors, you can see that we do have a neighbor relationship with R5 and R3. Now, because this is an internal router, I'll show you that this is going to be kind of anticlimactic. Show IP OSPF is a command that will show you what type of OSPF router you are running. Hit enter, and it's going to give you, like I said, a buttload of stuff here. Generally, right around in this area, it's going to tell you something like it is an area border router or it is an autonomous system boundary router. It will not identify internal routers. It also will not identify backbone routers. So what you're going to have to do here to figure out what this is if it doesn't say that it's an ABR or an ASBR, then that means that by definition it is an internal router. If you go down to this bit here, it'll tell you which areas are running. In this case, we only see a single area, which is area 0, which it nicely tells you is a backbone area. So we know that this is not an ABR. We know that this is not an ASBR. Therefore, it must be an internal router. And because it has at least one interface, in this case, it's got all of its interfaces, well, all being both, in area 0, which is a backbone area, it is also a backbone area. It's not going to tell you in big flashing neon lights that this is a backbone area or that it is an internal router. And we can see the same thing on R3. Same deal. Doesn't show us anything here. We're in backbone area 0, and then R5 is going to be the same deal. So like I said, kind of anticlimactic there. And as we look at the ABR and ASBR, this command will be of a lot more help to us. Okay, so now we've added a couple routers to our topology, and these routers are going to be in different areas. So now we've added R1 and R4, and we also added a couple of different areas here. So we've got area 21 up here and area 24 down here. So now this is where the ABR or area border router comes into play. And it's going to be pretty easy, like I said, when you're looking at the topology to determine which router is an ABR. Well, it's going to be the one that has interfaces in more than one area. And there's only one of these dogs out here, and it's R2. R2 has interfaces in area 0, which makes it by definition a backbone router. And then it has an interface in area 21 and area 24. So it is by definition an ABR or area border router. Now, R4 and R1 have all their interfaces in a single area, so they are going to be internal routers, but they will not be backbone routers because they do not have at least one interface in area 0. So R3 and R5 are going to remain as backbone routers as well as internal routers, and we'll see that in the next slide. And exactly as I told you it would be. So R1 and R4 are internal because they only have interfaces in a single area. Same thing with R3 and R5, but they also get the added designation of being backbone routers. R2 is still a backbone router because it has at least one interface in area 0, and it's an area border router because it has at least one interface in a different area. So just by definition, anytime you have an ABR, an area border router, because at least one interface has to be in the backbone area, which is area 0. If you have an ABR, it's automatically going to be a backbone router. So let's pop on over to the CLI and see what's going on now. Okay, so now we're on R2. Let's go ahead and do a show IP OSPF neighbors, and you can see that we have a couple new neighbors here. If we do a show IP OSPF interface brief, you see that these new neighbors are in non-area 0 areas. So we've got 00/0 is in area 21 and 00/3 is in area 24. So now let's go ahead and issue our show IP OSPF command and see what we get. Holy cow, we get a ton of stuff here, and we get well over a page worth of stuff. But what we're looking for specifically is this line right here that says it is an area border router. So if we want to be concise, we could just go ahead and include it is, and there you go. So we are running as an ABR, and that's what we expected. So let's go out to one of our new guys here, and let's pick R4, clear all this garbage out. And if I do a show IP OSPF neighbor, I have a neighbor adjacency with R2. Let's go ahead and do a show IP OSPF. And what do you think is going to happen? Now remember, this is in a single area. It's in area 24. It is not connected to the backbone area. So yeah, we're going to get our output that doesn't show anything. So if we were to pipe in it is, and capitalization is important with that first word, it doesn't return anything. So we know that it's not an ABR. We know that it's not an ASBR. We know then, of course, that it is an internal router, But then when we go ahead and take a look at the show IP OSPF, we can see that the area that it's in is area 24. There's only one area configured here, and because it's not in the backbone area, it's not going to be a backbone router. So this guy is just an internal router. Okay, so we tacked on one more router, R6, to our topology, and R6 is going to be running EIGRP, so it's a different IGP. So in this case, let's say that we bought a company and R6 came along with the deal. R1 is connected to our OSPF domain, while it also has a connection to the EIGRP domain. So it's got both routes. Now, a couple of important bits here. At this point, if you are not redistributing routes, then this is not an ASBR. So looking at this, you're like, okay, this is an autonomous system boundary router because I can see that this is the OSPF domain and then this is a EIGRP domain. Unless it's actually redistributing routes, and actually only if it's redistributing into OSPF is this actually considered an ASBR, an autonomous system boundary router. And that's the last time I'm going to say the full version of that because that's too many words. So I guess if you get this on an exam, you will want to clarify whether or not redistribution is occurring and also which direction it's occurring. If you're redistributing OSPF routes into EIGRP, this is not considered an ASBR, and we'll see this on the CLI. For the purposes of this slide, we will assume that EIGRP is being redistributed into OSPF, and actually it's going both ways, but it just has to be going into OSPF. So this is an ASBR. So none of the other routers have changed as far as their OSPF router types, just R1. Now this goes back to the quote-unquote controversy about what is and what is not an internal router. This router is an ASBR, but all of its OSPF enabled interfaces are connected to a single area. So depending on the definition that you use for internal router, it could be an internal router. Now all of its interfaces are not connected to a single OSPF area because it has an interface that goes to an EIGRP domain. This is why I would say that the true definition of an OSPF internal router is that all OSPF enabled interfaces are connected to a single area. Because what we could have here is if we don't have redistribution occurring, then this is not an ASBR. We just discussed that. So at that point, not all of its interfaces are in a single OSPF area because it has an interface that's an EIGRP. So that means it's not an ASBR, not an area border router because there's no other area here. With our definition of all interfaces having to be in a single OSPF area, it's not an internal router, and it's also not a backbone router because it doesn't have a connection to OSPF area 0. So what the hell is it? It's a nothing. It's a null router. So I think that the actual definition is all OSPF enabled interfaces being connected to a single OSPF area defines you as an internal router. Now, in the real world, this doesn't make a damn bit of difference because we don't care. In the academic world, as far as Cisco exams are concerned, it's going to be a bugaboo. I don't know if you'll get a question like this, but if you do and you have to pick a definition, I would go with the all OSPF enabled interfaces for my definition, because with the definition that simply says all interfaces must be in the same OSPF area, that means that you could end up with an OSPF router that has no OSPF router type. I don't think that's an end result that they want to happen. But anyways, like I said, this is trivial. I don't mean to waste so much time on it. It's just that that's why I have the question mark for the definitions at the beginning. All right, so I'm on R1. If I do a show IP OSPF neighbors, you can see that we do have a neighbor relationship with R2. If I do a show IP protocol summary, you can see that we are running both OSPF and EIGRP. So now if I do a show IP OSPF interface brief, and if you're not familiar with these commands at this point, don't worry about this. This is just pointing out the obvious that we're running both OSPF and EIGRP on here. So these are the interfaces that belong to OSPF, and that's at serial 0/0 connection to R2. And if I do the same thing with EIGRP, there's no brief option for that. You can see that 00/1, which is going out to R6, is running EIGRP. If I do a show IP route, you can see that we are learning one route from EIGRP. And again, if you're not used to this command, D means EIGRP, O means OSPF. We're not going to worry about the IA. That's for another lesson. And one last thing to show you is I'm going to do a show run include redist. And again, you don't have to know much about redistribution. I'm just trying to prove to you right now that I'm not redistributing between these two IGPs. So you're running two separate routing protocols on this router, and they're not redistributing at this point. And the reason I'm showing this is because now if I do a show IP OSPF, we'll get all this output, And you'll notice that we don't have anything in here that says it is an ASBR. We don't have anything that says it's an ABR either, which we don't expect. And we do see that it only has one OSPF area that it's connected to, and that's area 21. So as we saw earlier, this would lead us to believe that the OSPF router type is an internal router. So there you go. That's where I hate to harp on this. That definition gets a little janky because we don't have all of our interfaces within a single OSPF area, because we do have an interface that's connected to an EIGRP domain, but all of our OSPF enabled interfaces are connected to area 21. So in my world, this is considered an internal router. Do what you will with that information. Also, what's important is that because we're not redistributing at this point, this is not an ASBR. When you look at a topology and you see that, you're probably going to want to ask a question. I don't know if you're going to be able to in a Cisco exam, but hopefully they have that information there. If they don't, go with the best answer and maybe put in some feedback saying, hey, you need to tell me whether this is redistributing or not. Because at this point, this is not an ASBR. Even though it's where it's situated on the topology, it looks like it should be an ASBR. And we're going to turn it into an ASBR, but I just wanted to show you that you do have to have redistribution, and specifically redistribution into OSPF. Because if I go into configuration mode here, and again, don't worry about these commands. If I go into EIGRP and I redistribute OSPF 1 into EIGRP, yeah, metric. I'm just making up a fake metric for any of you guys that know this command. I'm just giving it whatever so that I've got redistribution. So now I'm redistributing OSPF into EIGRP. And if I jump over to R6, which is my EIGRP router, I do a show IP route. These DEX, these are external EIGRP routes, are routes that I'm learning from OSPF. But if I pop over back to R2, if I do a show IP route, I don't have any. I would see O with an E, in this case E2, external OSPF route. I'm not learning any routes in OSPF that have been originated in EIGRP. The long way around that is that even though I've got redistribution going, it's not going into OSPF. So now if I do a show IP OSPF, you can see here, read through all of it, but it doesn't say it is an ASBR. We're still an internal router as far as I'm concerned. So if I did this and just piped for it is, nothing shows up. So let's go ahead and turn this into an ASBR, and the way that we need to do that is we go into configuration mode, go to router, I'm going to redistribute EIGRP 100 subnets. Again, don't worry about this command. This will be covered in the redistribution lesson. So now I'm redistributing these EIGRP routes into OSPF. So I pop down to R2, reissue my show IP route command. I should see a number of routes, well actually only one, that's going to have O followed by an E2, which means it's learned externally. Oh, two. So I've got two routes here that I'm learning externally. Those are the EIGRP routes. Pop back up to R1, and now I'm going to issue my show IP OSPF. And the line that we're looking for is right here. It is an autonomous system boundary router. So you see that for this to actually be an ASBR, you have to have redistribution into OSPF. Okay, I'm going to do one last bit here. I'm going to pop back down to R2. And if you remember from our diagram, R2 is an area border router. It's sitting between area 0, which is the backbone, and area 21 and area 24. So if I do a show IP OSPF and include it is, you can see here, it is an area border router. What I want to show you here is that it can be both an area border router and an ASBR. And what I'm going to do is I'm actually going to redistribute an interface into OSPF. Again, don't worry about this. Let me do show. Actually, loopback 0 is not being advertised. So what I'm going to do is I'm going to go under my router OSPF1 process. Just going to do a redistribute connected, which means redistribute the connected interfaces into OSPF subnets. I need to have that command, and I'm going to give it a metric of 69 just so that I know that it originated. Again, don't worry about this command. All that I want to do here is that I want to have this router doing redistribution. At this point it's redistributing the connected interfaces into OSPF, which is basically just amount to that loopback 0 interface. So it's doing redistribution, and it's also bordering two areas with interfaces in the backbone. So it's really doing both ABR and ASBR work at this point. And if we issue our show IP OSPF command, I'm just going to filter for the router type, hit enter. I just want to show that you can do both. You can be both an area border router and an autonomous system boundary router at the same time. Okay, I hope I didn't lose anybody with those last couple of bits there. It's just meant to show you what specifically has to happen for an OSPF router to become an ASBR, and also to illustrate the fact that you can have a router being both an ABR and an ASBR. So let's go take a look at the verification command. We already know this guy because we've seen it in action, and it's to show IP OSPF, and it will, as we saw on the CLI, give you a ton of information. There's a lot of good stuff in there. What we're specifically looking for is this line here that starts with "it is." It's going to tell you what type of OSPF router it is, and it's either going to be an area border router, an autonomous system boundary router, or both. And as we saw earlier, if this is just an internal router, it's not going to tell you that. It's also not going to tell you that it's a backbone router. You'll have to get that information from the rest of the IP OSPF output. And again, just to hammer this home for the last time, if it doesn't tell you it's an ABR or an ASBR, then that means it must be an internal router. And if you go through that process and figure out that your router is an internal router and you have at least one connection to the backbone area, which is area 0, then that means it is also a backbone router. All right, let's wrap this guy up. There are 4 different types of OSPF routers, and they're going to be determined by a router's function and or location within an OSPF area. And the first of these types is an internal router. And you'll notice that I have the definition as all OSPF interfaces must belong to the same OSPF area. I think that we definitively shown that that is the true definition, that this refers to OSPF interfaces. Now, you saw in the first slide I had a question mark on there. There are definitions out there that just say all interfaces must belong to the same OSPF area. I think we've shown that that is not in fact true, but you choose a definition that you prefer. So then a backbone router just means that that router has at least one connection to area 0, which in OSPF is known as the backbone area. Those two, not that big a deal. The next two guys do have interesting properties, and we will be delving into these quite deeply in future lessons. The first of these is the area border router, or ABR, and this router is going to have at least one interface in area 0, which is the backbone area, and then at least one interface in another non-area 0 area. And the final one is the Autonomous System Boundary Router, or ASBR, and that is in a nutshell just any OSPF router that is performing redistribution into the OSPF domain from another routing source, be it RIP, EIGRP, BGP, whatever. And as we saw in the CLI, simply because you have different routing protocols running on a router does not automatically make it an ASBR. And the direction of redistribution is also important too. If you're redistributing out of OSPF into another route source, that does not make it an ASBR. It's only when routes are redistributed into OSPF on a router that that router becomes an ASBR. One other quick thing I don't have on here is that these are not exclusive. You can have a router be up to 3 different types at the same time. It can't be an internal router and an ABR at the same time, but it could be a backbone, ABR, and autonomous system boundary router, for example, all at the same time. And the verification command for this is the show IP OSPF exec command. It's going to give you a lot of output. What we're looking for is the it is an, and then it'll tell you whether it's an ASBR or an ABR. It will not, as we saw, tell you whether it's an internal router or a backbone router. You're going to have to look a little closer at that output to figure out which of those it is. Anyways, thank you once again for joining me in the Packet Lab. As always, I hope this helps you on your route to becoming a network